So what you're looking at here is the formula that we will use as our differentiation for product rule. And when we apply this formula is whenever we have, say, a function that's equal to, say, y equals u times v, where in this case u and v, they are representing some form of terms that's being multiplied. So let's say those terms are, let's use y equals 3x squared multiplied by, say, sin 2x. Now this is where the product rule comes in, because we have these two terms that are being multiplied, and this, unlike our previous differentiations that we have looked at, this here requires a more complex rule, but it's simple when we break it down in steps, which we are going to do now. So the first thing that we need to look at here is what are our terms that we are multiplying, and the first term is our 3x squared, and the second term is our sin 2x. So we're going to apply the product rule now. So our first step here is just to say let u equals 3x squared. So we are assigning 3x squared to u, and we're going to assign v equals sin 2x. Now the purpose of doing this, just in case you're wondering, is so that we can differentiate each of these as an entity. So what that means here is we're going to have to differentiate our term with u. So what we do here, we're going to say du dx is equal to, so what is that when we differentiate it? That's going to be 2 times 3. So we're going to have 6x and take 1, so 6x to the power of 1. So that's the first bit being differentiated. So we know what du dx is now. And then our second step, of course, is to differentiate our sin 2x. So for that, we're going to have dv dx is equal to, and this is going to be 2 cos 2x. Now, just in case you don't understand these differential equations, I've done 2 previous videos that led to this point here. So if you're missing the beat as to what's happening, you can have a look at those videos. So what we're going to do now, we're going to put all of this in our big formula, because as you can see, we have a term here for u, we have a term for v, we have a term for du dx, and we have a term for dv dx. And if we go back to our formula right here, then you can see that all of those terms that I've just identified, all 4 terms, that's what's been used to make up our formula. So let's now plug and play. So just for clarity, so you can follow as I'm doing this, I'm just going to rewrite the formula so you can see as I'm substituting the terms. So let's substitute these terms now and see what we get for our final answer. And just before we do that, I always forget to ask you to subscribe to the channel, to give the video a like, because it really means a lot to me to grow this channel, to help a community of like-minded people, and I would really appreciate if you could do that. So let's substitute the terms now. So our u term up top there is 3x squared. So that's substituting the u, and I'll use a different color so you can distinguish. The dv dx is our 2 cos 2x, so that's 2 cos 2x for dv dx, plus our v term up top is sin 2x, and our du dx term, du dx is 6x. So to simplify all of this then, so if we were to multiply our 3x squared with our 2 cos 2x, that's just going to be the same as us expanding a bracket right there. So that's just going to leave us with 6x squared and cos 2x. And then over on this next side, this is 6x times sin 2x. So be careful not to multiply this 2x, because this 2x is a part of this entire function. So this is what we're multiplying. So this can only be 6x times sin 2x. So that's for that one. And what we can actually do here is to factorize this so it looks a little bit tidier. So if you look at the highest factor for both of these terms, you will see that we can factorize our 6x. So if we factor out our 6x and just divide through now by that, then 6x into 6x squared, that's just leaving us with x cos 2x, plus 6x will cancel 6x there, so that's just going to leave us with sin 2x. That's as far as it really goes. So there are lots more examples which I'm sure I will go through in the next couple of videos, but for now this is the product rule and this is how you apply it. And once again, I'd really appreciate it if you could subscribe to the channel, give the video a like, and in the next video here we're going to look at the quotient rule.